Hey.
This is your office?
Yeah. Move it on up a little bit.
That's good.
Thank you.
All right,
Hey.
Major. It's time for you to head on somewhere soon.
Yeah, stats1. This. God, we only want it on every word. Give it up, the living God. Give it up, the living God. We want to know you more and more. We're hanging on every word. Speak to us, oh God. Spirit of the living God, Spirit of the living God, we only want to hear your voice. We're hanging on every word. Spirit of the living God, Spirit of the living God, we want to know you more and more. We're hanging on every word. When you speak, when you move, when you do what only you can do. Changes us, changes what we see, and what we see. In the room, when you do what only you can do. Changes us, changes what we see, and what we see. Changing everything. Spirit of the living God, Spirit of the living God, we're leading into all you are. Everything else can wait. Spirit of the living God, Spirit of the living God, come now and breathe upon our hearts. Come now and have your way. Sweet, sweet, in the room, you move our fear. And when you move us to tears. Move us to tears. You move us to tears. When you fall, you fall. We fall on our knees. You fall, we fall on our knees. We fall at your feet. You fall, we fall on our knees. We fall, we fall at your feet. When you speak, when you do, when you do what only you can do, it changes us, it changes what we see and what we see. When you come in the room, when you do what only you can do, it changes us, it changes what we see and what we see. Okay, hello class. It's me, Dr. Major. I apologize for the technical difficulties that we had earlier today, but it's okay. We're gonna press on and we're gonna focus on the information that we would have learned today if we had class. So we're gonna start off by talking about the difference between a population and a sample. So, a population refers to a collection of people, but it doesn't necessarily have to be limited to a group of people who could be measured or in whom the researcher is interested in. So, if you remember back to maybe some of your early research design classes, we talked about the difference between a target population and an accessible population. This term that you see on the screen right now is just an all encompassing version of those different types of populations. From the population, we draw what's called a sample. A sample allows you to collect the data from smaller groups that represent the larger population. In the little image that you see on the right side of the screen, you'll see that the big state is supposed to be the larger population, and then there are smaller samples that are drawn from that larger population. We tend to prefer random samples over convenient samples, but there are times when we only have the choice of working with convenient samples, and so that's what we work with. The sample itself can be broken up into smaller subgroups or smaller conditions, depending upon the kind of research that you're doing. So for us visual folks, we have the population, and from the population, we draw the sample. Let's talk about some definitions pertaining to statistics. So, when we're talking about statistics, first we talk about data. So, data refers to measurements or observations. An individual measurement is considered a data point or datum, and a collection of measurements is a data set. So, if I told you that the average height for women that attend Howard University is 5'5" and 3/4, that itself is a data point. Hi everyone. I am so sorry about the technical issues that we had earlier today, but I'm so glad that we were able to press on and to keep going with today's lecture. I'd like to start off by talking about the difference between a population and a sample. So, population refers to a collection of people, but we're not limited to people who can be measured or in whom the researcher is interested in. So, the population could be animals, it could be shoes, it could be blood samples, etc. So, these are different examples of how we could construct a population. We tend to draw smaller samples from the population. So a sample allows you to collect data from smaller groups that represent the larger population. Ideally, the sample should be simply a subset. Hi everyone, it's Dr. Major, and today we're going to just pick up where we left off in terms of learning statistics. So the first thing we're going to do is talk about the difference between a population and a sample. So a population refers to a collection of people who could be measured or in whom the researcher is interested. Your population is not limited to people. It could be cars, it could be farm animals, it could be whatever it is that you're studying. We tend to talk about subsets of the population, which we'll define as a sample. So, a sample is a subset of the population, and it allows you to collect data from smaller groups that are representative of the larger population. We tend to prefer random samples over convenient samples, just because random samples tend to be more representative of the population that we're interested in. The population is like the large group, and the sample is a subset of that larger group. Now let's talk about some definitions. So, a data point or a datum refers to measurements or observations. It refers to the individual measurement. A collection of these measurements is called a data set. So, if I were to ask 10 people to report their grade on their last statistic exam, each individual grade would be a data point. Together, those grades would be a data set. A statistic, however, is a value derived from either all of the data or a measurement within the data. For example, the average number of heartbeats per minute at rest for women who play for the Washington Mystics, that's a statistic. Or the maximum height for women who play for the Washington Mystics, that also is a statistic. When we say statistics, when the term becomes plural, we're referring to a collection of numerical facts, observations that have been organized into numerical form. Statistics also refers to a branch of mathematics that's concerned with the collection, analysis, interpretation, and presentation of masses of numeric data. So this right here is an image of Romare Bearden's painting called The Block. And you'll see that this is just a subset of that painting. And the reason why I'm showing you a subset is because I want you to pay attention to some of the features that you see within this painting. So you see on the right side of the screen, we see an angel and a woman. Kind of towards the middle, you see another angel, and they're actually flying out the top of a funeral home. On the left side of the screen, you'll see a liquor store. All of these are a small snapshot of what's happening in the larger painting that Romare Bearden did. So I tend to show this smaller portion to show that as researchers, we tend to work with sample data to draw inferences about our entire population. We use the sample data to compute what are called descriptive statistics. In our descriptive statistics, they describe, they characterize, or they classify the data by summarizing them into understandable terms, hopefully without losing or distorting information. Information can be lost or distorted if we choose to use the wrong descriptive statistic to represent what we're interested in. Inferential statistics are a little bit different. Inferential statistics consist of parametric statistical techniques which are used to make generalizations about population characteristics by studying a sample selected from the given population. So we use the sample statistics to draw inferences about what's happening in our population. Some examples of both types of statistics include the mean, the median, the mode, frequency tables, bar graphs, percentages. Those are examples of descriptive statistics. Our inferential tests or inferential statistics include Spearman's Rho, students' t-test, our one-way independent samples ANOVA, our two-way independent samples ANOVA, etc. Let's talk about our descriptive statistics. So we have some examples of descriptive statistics, which include tables, graphs, our measures of central tendency, measures of variability, and measures of association. We'll talk about the first four groupings now, and then we'll talk about our measures of association towards the end of the semester, because technically they can be descriptive statistics, but they could also be inferential statistics also. So what you see here is a frequency distribution. So this is the data from the beginning of the semester survey that we posted on Blackboard. In this frequency distribution, notice that the rows represent the different classifications and the columns represent different types of data. And in your frequency distributions, this is how we tend to set them up. So if we look at the column that says frequency, this simply reports the number of people that fall in each of the categories. So in this data set, we had 3 people who said they were seniors, 12 who said they were juniors, 32 sophomores, and 0 freshmen. If we add all of these together, we'll notice that they equal 47, which is the total at the bottom of the screen. Your percentage is in the next column. Now, let me just say this about our frequency distribution. You can set your frequency distribution up however you would like to set it up in terms of where the columns are placed, but I just chose to do this just to kind of give you a quick review of a frequency distribution. So in the percent column, you'll notice that we simply took the frequency and divided it by the total. So 3 over 47 got us 6.38, and we multiplied it by 100 to get 6.38%. For the juniors, we took 12 divided by 47 and multiplied it by 100 to get 25.53%. Etc. And so you can read in your textbook about how we calculated the other types of frequencies in our frequency distribution. But this is just one way that we show and present data one way that we show or present data for ourselves and to other people. It helps us to summarize what's happening in our sample in a nice and succinct way. Another way that we describe our data is through using graphs. So on the left, you'll see a scatter plot. On the right, you'll see a bar graph, and both of these, histogram, representing different types of information. This data was gathered by the Pew Research Center, and the graph on the right shows that mothers more than fathers experience career interruption. So this study was about the differences in the gender pay gap, and on the left hand, you'll see the difference. On the right graph, you'll see the difference between mothers and fathers. So 42% of mothers say they had reduced work hours, whereas only 28% of fathers said they had reduced work hours. Another interesting statistic from this graph is the percentage of men and women that turn down promotions. 13% of the mothers turn down promotions and 10% of the fathers promotions. We also summarize our data using what are called measures of central tendency. So our measures of central tendency refers to a single numerical value that express what's typical of values in a distribution or values in a data set. The 3 that we're going to discuss are the mean, the median, and the mode. So the mode simply is the score that occurs the most frequently. It's the simplest of the measure of central tendency because it just tells you the category or the group that had the most participants. A distribution can have more than one mode. If it does have more than one mode, then it's considered bimodal. If it has 2 modes, it's considered bimodal, or we could say it's multimodal. We could have 3 modes, 4 modes, etc. The point is you have a score or scores that are occurring the most frequently within your data set. One nice thing about the mode is it's not impacted by an outlier. And an outlier is a score that is extreme relative to all of the other data points in your data set. So if you were looking at, let's say, age, and most of your participants are between 25 and 35 years old, and you had one participant who reported that their age was 110, you may have some questions about that age of 110. Now, this participant may really be 110, or there may have been a recording error on the side of the participant. Maybe they were writing too quickly, maybe they weren't paying attention, maybe they were just trying to be funny. But either way, that 110 is an outlier relative to all of the other age data points in your data set. So how do we find the mode? One way to find the mode is to arrange the scores from lowest to highest and then count the frequency of each score. The score that occurs the most frequently is considered the mode. In this data set, I could ask you to identify the mode, and you would tell me that the mode is 36. The median is the middle number in a distribution of scores. 50% of the scores fall above the median and 50% of the scores fall below the median. It's the score at what we call the 50th percentile. It's also not impacted by outliers. If we wanted to find the mean, we would array the data from smallest to largest. If we had an odd number of scores, we're simply going to select the score that falls right in the middle. If we have an even number of scores, we select the two middle scores and then divide by 2. So in example A, the data has already been arrayed for you. And so the middle number in this data set is 8. So that's going to be our median. In this second data set, the data hasn't been arrayed. So let's array it for you. So we took the 10, 4, 2, 8, 12, 3, 5, and 7 and put it in order. So we have 2, 3, 4, 5, 7, 8, 10, and 12. The middle two scores are 5 and 7. So what we're going to do now is take the average of these two scores by adding them together. 5 plus 7 equals 12, and then dividing it by 2 to get 6. The median in this situation is 6. Another measure of central tendency is the mean. So the mean is the arithmetic average of the scores in the distribution. It's the most reported measure of central tendency, and of the three that we've talked about, it is sensitive to outliers. How do we calculate the mean? We find the sum of the scores in a distribution and then divide by the total number of scores. So if we use 4, 5, 5, 5, 6, 7, 8, 9, 9, 9, 10, 11, and 12. And if I asked you to find the average, you'd first find the sum, which equals 100. You divide that by 13 because there are 13 data points, and you find that the mean is 7.6923. Let's talk about combining the scales of measurement that we learned last week with our measures of central tendency from today. If you have data that's measured on a nominal scale, the measure of central tendency that you only can report, that you can only report, the measure of central tendency that's going to give you the most information is going to be the mode. If you have ordinal level data, you could identify the category that occurs most frequently, but the median is going to be the one that's the most informative. If you have data that's measured on an interval or ratio scale, you could compute the mean, the median, and the mode, but the mean is going to be the one that gives you the most information. Now notice I put interval and ratio level data in the same row in our table. That's because we tend to treat interval and ratio level data the same when it comes to computing our descriptive statistics and our inferential analyses. So this is just an example that you can do on your own time. A clinical psychologist is comparing two methods for reducing anxiety in high school students. A certain test was used to measure the degree of anxiety. A high score on the test indicated greater anxiety. 12 students obtaining high and nearly high scores were used in the experiment. 6 were selected at random from among the 12 problem cases and treated with method 1. The remaining 6 students were treated with method 2. Both treatments were continued for 1 year. Each student was given the ART test at the end of the year with the results shown in the table below. I could ask you to compute the mean, the median, and the mode for each group, and I recommend that you do that on your own time. When you compute the mean, the median, and the mode, it's important to take it to the next step and interpret this information. So you would say in this sample, students treated with method 2, and then in parentheses, you put y bar equals 71. Y bar stands for the mean for group 2, which is that subset. So y bar equals 71 had lower levels of anxiety on average than students treated with method 1. So the lower levels is our comparative statement between the two groups. So you want to make sure you include that in your interpretation. One group is either higher than the other group, one group is lower than the other group, or the means are the same. And notice that we end by stating the average for the comparison group. Also notice that I started by saying in this sample because we're dealing with sample data for this example. So we're specifying that we're talking about a specific sample. If we had an entire population, then we would say the entire population. If we were interpreting the median, we would say in this sample, students treated with method 2 had lower levels of anxiety. Median 2 equals 70. Then students treated with method 1, median 1 equals 86.5. If we're interpreting the mode, we would say the modal anxiety scores for students treated with method 2 was 70. However, the modal score for students treated with method 1 was 80. Now let's talk our measures of variability. So a measure of variability is simply a numerical value that describes how spread out your scores are in the distribution around a measure of central tendency. The more spread out the scores are around the measure of central tendency, the more variability you'll see in your scores. So the less the scores are spread out around the measure of the measure of central tendency, the less variability that you see. Measures of central tendency and measures of variability should be reported together. And we'll talk about which measures of central tendency should be reported with which measure of variability very shortly. Actually, right now. So if we have data that's measured on a nominal scale and we report the mode, the measure of variability that we should report is our index of qualitative variation. Let's talk about that now. So our index of qualitative variation is an index of the spread in the scores in the data about the modal category. So it tells us how spread out are the scores around the modal category. One method for computing the IQV is to subtract the relative frequency at the mode from 1. So to do 1 minus relative frequency at the mode. How do we do this in more detail? First, we're going to calculate the frequency for each category. We're going to calculate the total. And then we're going to calculate the relative frequency for each category, which is simply the frequency for each category divided by the total. And then we're going to identify the relative frequency for the modal category. Finally, we're going to subtract that number from 1. So this is just some data from a hypothetical research study where a social service agency recorded the number of clients that utilized their services over the course of 1 year. And so each row represents a different season, and the frequency for how many people utilize the services are in the frequency category. So in spring, 30 people use the services. In the fall, 20 people use the services. To compute our relative frequency, we're simply going to take the frequency for spring and divide it by 100, and that'll give us the relative frequency for spring. So 30 divided by 100 equals 0.3. The relative frequency for summer is 40 divided by 100, which equals 0.4. The relative frequency for fall is 20 divided by 100, which is 0.2. And the relative frequency for winter is 10 divided by 100, which is 0.10. The sum of your relative frequency should always equal 1. Now we're tasked with identifying the relative frequency for the modal category. Remember, the modal category is the category with the most participants, the category that occurs the most frequently. In this data set, summer was the modal category. So to finish things up, we're simply going to take 0.40 and subtract it from 1 to get 0.60. That's going to be our index of qualitative variation. Here's another example that you can do if you'd like to practice this more on your own time. So we've dealt with our index of qualitative variation. Now let's deal with our semi-interquartile range. The semi-interquartile range is the measure of variability that you report when you have ordinal data, and the most appropriate measure of central tendency is the median. We have two methods for computing the IQV. We have multiple methods for computing, let me try that again. We have multiple methods for computing the semi-interquartile range. In this class, I want to talk to you about how to compute Tukey's method for computing the semi-interquartile range. The semi-interquartile range gives a typical distance that a score is from the median. So the first step is to find the median. From there, you're going to find the median of the distributions that you just created. So your median takes your distribution of data and divides it in half. So you're going to find the halfway point for all of the scores that are below the median and the halfway point for all of the scores that are above the median. The halfway point for the scores below the median is called your 25th percentile. The halfway point for the scores above your median is the 75th percentile. So you're simply going to take your 75th percentile, subtract the 75th percentile from the 25th percentile. Excuse me, it should be subtract the 25th percentile from the 75th percentile, and that gives you your interquartile range. Your semi-interquartile range is going to be that number divided by 2. So I fixed it. So you're going to subtract the 25th percentile from the 75th percentile. And that's how you get your interquartile range. The semi-interquartile range is simply Q3 minus Q1 divided by 2. Let's look at an example with an even number of scores. So if we have 80, 80, 86, 87, 91, and 92, first step is to find the median. And the median is going to be halfway between 86 and 87, which is 86.5. Now we need to find the median for the lower set of scores, the scores that are below the median. Or another way to think about it is the score that falls in the middle of the lower set of scores, the scores below the median. That value is 80. We call that Q1. The score at the 75th percentile is 91. To compute my IQR, I'm simply going to subtract the two numbers. So 91 minus 80 gets me to 11. My semi-interquartile range is going to be 11 divided by 2, which is 5.5. This is just another example if you wanted to find the semi-interquartile range if you had an odd number of scores. So you can ignore the data for method 1 and just focus on the data for method 2. So the median is still going to be the middle score, but since we have an odd number of scores, we just have to select that middle point. In this example, the middle point is 70. Now we have to create two distributions. We have our lower distributions, which are the scores below the median, and the median of the two scores, the median of the scores, below the median of 70 is somewhere between 69 and 70. So that's going to be 69.5. The median for our upper distribution of scores is going to be somewhere between 75 and 78. So we're going to add 75 and 78 together and then divide by 2. Let's do method 1 instead of doing method 2. So with method 1, the median is 87. The median for the lower set of scores is 83. The median for the upper set of scores is 91.5. So when you subtract 91.5 minus 83, you get 8.5. And then when you divide that by 2, you get 4.25. On Thursday, we will talk about variance and standard deviation. In the meantime, what I want you to do is watch the video that we posted on Blackboard about how to compute variance and standard deviation. Thank you. Bye.
by 30 divided by 100 equals 0.3. The relative frequency for summer is 40 divided by 100 equals 0.4. The relative frequency for so I fixed it. So you're going to subtract the 25th percentile from the 75th percentile. And that's how you get your interquartile range. The semi-interquartile range is simply Q3 minus Q1 divided by 2. Let's look at an example with an even number of scores. So if we have 80, 80, 86, 87, 91, and 92, first up is to find the median. And the median is going to be halfway between 86 and 87, which is 86.5. Now we need to find the median for the lower set of scores, the scores that are below the median. Or another way to think about it is the score that falls in the middle of the lower set of scores, the scores below the median. That value is 80, call that Q1. The score at the 75th percentile is 91. To compute my IQR, so you can ignore the data from method 1 and just focus on the data from method 2. So the median is still going to be the middle score, but since we have odd number of scores, we just have to select that middle point. In this example, the middle point is 70. Now we have to create two distributions. We have our lower distributions, which are the scores below the median, and the median of the two scores, the median of the scores, below the median of 70 is somewhere between 69 and 70. So that's going to be 69.5. The median for our upper distribution of scores is going to be somewhere between 75 and 78. So we're going to add 75 and 78 together and then divide by 2. Let's do method 1 instead of method 2. So with method 1, the median is 87. The median for the lower set of scores is 83. The median for the upper set of scores is 91.5. So when you subtract to 91.5 minus 83, you get 8.5. And then when you divide that by 2, you get 4.25. On Thursday, we will talk about variances and deviations. In the meantime, what I want you to do is watch the video that we posted on Blackboard about how to